Okay, so we can do volumetric analysis with redox reactions as well. Everything's exactly the same. This is just a bit of practice with your half equations. There's a few ways we can tell that this is a redox reaction. You know with your posters that a primary alcohol can be turned into an aldehyde and then can be turned into a carboxylic acid. A secondary alcohol, so they're all redox reactions. Secondary alcohol can be turned into a ketone. So this is a secondary alcohol and it's turned into a ketone because you've got the OH group in the middle. And so when you add oxygen to it, you form a carbonyl group in the middle. Technically, we're not supposed to name these things, ketones or aldehydes, but on the exam they have used names. So ketone ends in -one, so don't get disturbed if you see a chemical with -one on the end. It's a ketone. And aldehydes end in -al. Propanal is an aldehyde. So we're not supposed to name it, but they've put them on exams. So we need to write an oxidation reaction, so we need some electrons. Oxidation is the loss, so our electrons have to be on this side, being lost. It's easier to write a balanced oxidation for these if we collect all the carbons, the hydrogens and the oxygens. So we've got 3 carbons, 3, 4, 5, 6, 7, 8 hydrogens and 1 oxygen. So that's our propan-2-ol, and we're turning it into this. So we've got 3 carbons, 6 hydrogens and 1 oxygen. Okay, so as soon as you kind of summarize it, it makes it really easy what you're going to do. So remember, we have to balance everything except the carbons and the hydrogens and oxygens. So the carbons balanced, oxygen's balanced. So the only thing that's not is hydrogens. So to balance the hydrogens, you just add hydrogen ions. You might remember with your pathways that you need an oxidizing agent, and down here you can see the oxidizing agent that we're using. So when you write your pathway, you need acid and either dichromate ions or permanganate ions. You need to know these ions, and you always put the acid on your pathway. So you can see why we need acid. Okay, so we need to put our electrons on. If you don't remember, oxidation's over here. It's really easy to see that there's no charge over there, so you have to balance out the charges. So you need to add 2 negative electrons to cancel out the 2 positive hydrogens so that there's no charge over here. So that's our half equation for this. Given the reactions below, write a balanced overall equation for the reaction between... Okay, so this is actually a different question. Sorry, I was thinking it was the same. So this could be reacting with the dichromate, or it could have been reacting with manganate. This particular reaction is reacting with the dichromate. So whole equation. This is one of the biggest whole equations that you would ever do. So I have written this out twice because I made a mistake the first time. Because it's so large, it's easy to sort of stop paying attention and make mistakes. So when you put 2 half equations together, you must make sure that the number of electrons is the same. So what's being lost is the same as what's being gained. So you can see 4 and 6 are different. So we need some number that 4 and 6 both go into, so that you could just multiply them. 4 times 6 is 24. But the smallest number that they both go into is 12. So to get to 12, you'd have to multiply this by 3, and to get to 12, you have to multiply that by 2. Okay, so all of your reactants are collected together as your reactants, and all the products are collected together as your products. So you have to make sure that you multiply 3 by all of these, and then 2 by this, and collect it. So 3 of those, 2 of these, twice that, twice that. So that's all your reactants, everything on the left. So I got most of the way through, and then I made a mistake here. So 3 of these, 3 of everything here, products, and 2 of those. And I started writing 2 of this. I forgot that I was doing the products. So be really careful. That it's easy to make a mistake. By the time you get down here, you kind of got sick of the whole thing. You think you know what you're doing, and then you go 2 of those rather than 2 of the product here. Okay, and if you've done this much work, you don't want to make a mistake right here. All right, this is the biggest kind of overall equation that you'd ever do. So normally we have to cancel out the electrons that have been used in the reactants, and the electrons that are produced as the product, cancel them out. So that's about the most cancelling that you would ever normally do. But this particular reaction, we've got hydrogen ions on both sides and we've got water molecules on both sides. So we have to tidy all that up. So water molecules, so we've got 3 on this side, 3 as the reactants and 14 as the products. So we can cancel out 3, get rid of it, 3 from each. So we'll be left just producing 11 water molecules. And we've got 28 hydrogens in the reactants and 12 in the products. So if we cancel out 12 from here, this all goes from here, and 12 from here will be 16 water molecules that we need. 28 minus 12. And then you just have to write out the entire thing again, just with this 16 hydrogens, making this and this, and 11 water molecules. Okay, and then you'll have your overall equation. I think you can do that without me.